Hello and most welcome to 1258. We will continue with Roberto Mangabeira, Unger, and we will today talk about his book, A Single Universe, with its important implications. I'll continue where I left off, page 136. I have to add, this is the longest read I ever done in my life. In all these respects, the non-cyclic view of succession is in a better place. It conjectures that we will never be able to explain the genesis of the fundamental structure of the cool-down universe on the foundation of the regularities that we observe in a universe marked by the stability of both this structure and of the regularities that it exhibits. Such a non-cyclic account of succession provides a basis for taking the less heroic and economical position that regularities do not antedate the structures manifesting them. Why indeed? It is a view that may seem paradoxical only to those who have embraced the dogma that the laws of nature are either eternal or non-existence, and that only if they are eternal can science do its work. We should be clear about what in this alternative way of thinking is speculative and what is not, and about the sense in which its speculative element may nonetheless connect with the empirical agenda of natural science, that the observed universe exists and that it must form part of a larger universe which we cannot observe in its entirety are matters of fact. All other universes, whether parallel or divergent, under the aegis of the idea of plurality, or predecessors to our own, are at the present time speculations. The difference is that the parallel or divergent universes of the thesis of plurality are not only unobservable now, but also forever beyond the reach of direct or indirect empirical investigation. Whereas previous universes or previous states of the present universe are likely to have left marks or vestiges that we can observe. Moreover, we may be able to simulate in our universe some of the conditions that attended its beginnings and prehistory. Even then, we cannot reenact the totality of an earlier state of affairs. The difference is also that we come to the ideas of plurality and of succession in radically different ways, with different relations to the interests of natural science. We devise the conception of plurality out of an attempt to make up for the radical underdetermination of many of our present physical theories. Notably, the string theory variant of particle physics. The compatibility with a multitude of universes other than our own. By contrast, we arrive at the idea of succession as a direct consequence of banishing from the interpretation of the standard cosmological model that the mathematical notion of an infinite initial singularity, which, like all versions of the infinite, can represent no real physical state of affairs. We reach it as well by fidelity to the practice of causal explanation and to its underlying assumption that every state of affairs must have causes, and that the relation between cause and effect is, by its very nature, temporal. Each after must have a before until we can see and think no longer. We are not entitled to mistake the limits of our understanding of the universe for a moment when something came out of nothing. We are then faced with a choice between the cyclic and the non-cyclic views of succession. We continue to lack any decisive empirical evidence or theoretical compulsion to choose one of these variants of succession over the other. Both views are speculative. There are nevertheless clues in what we already know about the history of our universe, as well as about the study of the workings of the parts of nature to which we have direct access on our planet and in the life around us. These clues suggest the mutable and historical character of all types of being or natural kinds, including the basic constituents of nature. From the recognition of this mutability and historicity, it is only a step to apply in cosmology the working assumption that we deploy elsewhere, where the structures emerge and change. So must the regularities that they exhibit and to which they appear to conform. These clues, taken together with the other arguments that I have here outlined, favor the non-cyclic variant of succession over the cyclic one. The grounds for preference are neither robustly empirical nor merely speculative. They display the hybrid form characteristic of the work by which natural philosophy acts as the scout of science and instigates the dissolution of the marriage between empirical insight and metaphysical preconception in ruling scientific ideas. 6. The argument from the reciprocal support of the ideas of the singular universe, singular existence of the universe, of the inclusive reality of time, and of the selective realism of mathematics. The thesis of the singular existence of the universe, extended by the idea of a succession of universes, should be judged not only on its own merits, but also as a part of a more comprehensive view. It is the conception that most fully coheres with the ideas about time and about mathematics, representing the other chief proposal of this book. It supports those ideas and receives support from them. It shares in both their strengths and their weaknesses. It's a tricky word here, a tricky combination of word. The claim that time is inclusively real can be established only if nothing, including the regularities of nature, remains outside the reach of time, invulnerable to change. The inclusive reality of time, I argue in chapter 4, remains in jeopardy unless there exists a preferred cosmic time such that everything that has ever happened in the history of nature can in principle be placed on a single unbroken time chart. Only then does time cease to be an accessory to something else, in particular to the placement of matter and the occurrence of motion. There must be such a preferred cosmic time for time to be inclusively real. And for us to be able to ask and to answer questions such as how old the universe is. There must be such a time, notwithstanding the objections resulting from the standard interpretations of general relativity. With their adoption of Lorentzian spacetime. As well as from the relativity of simultaneity established by special relativity. So you see here how important that the theory also is inside the universe, a thing that is incredibly hard to understand. We are so used to think faulty. I would put in parentheses here transcendental or otherworldly, not belonging to this world. But it should not be termed abstract, because if something is truly abstract, intellectual, then it has to be in this world, because abstract is still working, something functionable. But outside the universe, it does not work. It's no stronger definition of wrongness than being or trying to be outside of the universe. I will repeat, only then does time cease to be an accessory to something else. In particular, to the placement of matter and the occurrence of motion. There must be such a preferred cosmic time for time to be inclusively real, and for us to be able to ask and to answer questions such as how old the universe is. There must be such a time, notwithstanding the objections resulting from the standard interpretations of general relativity. With their adoption of Lorentzian spacetime, as well as from the relativity of simultaneity established by special relativity. These requirements are in turn readily satisfied only if there is one universe at a time, with the qualifications that the suggested existence of branching universes may suggest. A succession of universes provides a physical basis for the existence of a preferred cosmic time, and thus as well for the inclusive reality of time. Such a succession makes it possible for the unified history of our universes to extend backward into a history of successive universes, or of phases of contraction and expansion of the single universal reality. However, as I acknowledge in chapter 4, the singular existence of the universe extending backward in time through succession is not a sufficient condition for the existence of a preferred cosmic time, although it may be a necessary one. We need to know how such a time can even in principle be perceived and measured. If it is not perceptible and measurable, the notion of a preferred cosmic time would be no better than the untestable conjectures of the multiverse view. Its theoretical advantages would be insufficient to justify its reception by cosmology. For a preferred cosmic time to have a legitimate cosmological role, the universe must also be so arranged by virtue of its relative isotropy and homogeneity that it provides a clock of cosmic time in the twin forms of its equal recession in all directions from preferred observers situated in positions expressive of that homogeneity and isotropy, and of the equal temperature with which its cosmic microwave radiation background strikes these same preferred observers from all directions of the sky. The clock of cosmic time is the universe itself, viewed with regard to some of its features. We have reason to believe that we live in such a universe, one in which cosmic time can in principle be recognized and measured, not simply asserted as the theoretical pre-commitment or dissolved into the countless space-time coordinates of the predominant interpretations of general relativity. There is another way in which the idea of succession of universes supports thinking of time as non-emergent rather than derivative from some other more basic reality. If time stopped at an initial infinite singularity, or if it were an aspect of a space-time continuum, as the leading interpretations of general relativity imply, it could not be fundamental. The dynamics of that singularity, or the geometry of that continuum, rather than time, would be fundamental. The ideas of singular existence and of succession offer an alternative to these views. In this alternative, time can be represented as non-emergent and inclusive. Indeed. Making science in a box, hey? An implication of the inclusive reality of time is the mutability of the laws, symmetries, and alleged constants of nature, despite their overwhelming stability in the universe that we see. Another implication is the metamorphosis of all natural kinds, of the types of being that there are, down to the most elementary particles and fields, in the non-cyclic variant of the idea of succession. We find a way of thinking about the coeval history of the structure and of the regularities. These ideas about the history of the universe are also reciprocally connected with a view of the relation of mathematics to nature and to science. The multiverse conception is intimately associated with a view of the prerogatives of mathematics in natural science, a theory that appears on its face to be physical, like the string theory variant of particle physics, turns out on closer inspection to be largely mathematical in its inspiration as well as in its expression. It countenances many more arrangements of nature at its most fundamental level than we can see it realized. The theorist then conjectures that all the unrealized arrangements must be enacted in universes other than our own, forever close to our inspection. In so doing, he reveals a prejudice about the privileged insight of mathematics into nature. If, however, there is no such immense plurality of the universes, ensuring the correspondence of a mathematical invention to a natural reality. If the universe is singular, if it is the outcome of a singular succession with features that cannot be inferred from mathematical abstractions. And if the stable structure of the cool-down universe amounts to the product of a unique history rather than the other way around. A deep chasm opens up between nature and mathematics. We must then rethink the relation of our mathematical ideas to the facts of nature and to the discoveries of science. The universe cannot be homologous to a mathematical object, much less can it be such an object. The applicability of mathematics to nature must be selective and conditional. We must reject the assumption that all constructions valid in mathematics, such as the notion of the infinite, have a guaranteed place in nature by virtue of their mathematical validity. Above all, we must guard against the anti-temporal biases of the mathematical imagination, which threaten to mislead us into discounting or even into denying the reality of time. The idea of the singular existence of the universe is not an isolated proposition. It forms part of a wider contest in natural philosophy and cosmology. The more complete our understanding of what is at stake in this quarrel, the more likely we are to do justice to each of its aspects. Implications for the agenda of cosmology. The remaining sections of this chapter addresses a number of debates that force upon us a choice between the conceptions of many universes and of a solitary universe, or more precisely, between the idea of a plurality of universes and the idea of a succession of universes or periods in the history of a singular changing universe. Before addressing these debates and their implications, it is useful to say something further about succession and its relation to plurality. If the universe has a history and began in a moment of extreme concentration, during which, and maybe before which, its present laws, symmetries, and regularities failed to hold, it developed either out of nothing or out of something. The idea that it developed out of nothing amounts to a way of acknowledging our inability to advance further in the work of scientific explanation. Alternatively, the universe developed out of something. Consequently, it has a prehistory as well as a history. Something preceded the traumatic events that cosmologists call the cosmological singularity. In these very early moments of the history of the universe, as the earlier discussion on the second cosmological fallacy suggested, causal connections may not yet have assumed law-like form, and the division of nature into enduring natural kinds may not yet have taken shape. To describe the situation in this way is to conjecture that some form of causal connection or continuity exists between successive universes or between different states of the universe. Before and after the earliest formative moments of the cool-down universe that we observe. To be sure, such causal connection or continuity between the present universe and a universe that may have preceded it cannot, in this view, be a connection or continuity that has for its basis immutable laws, symmetries, and constants. Change that is so radical poses a conundrum that we have already mentioned, to which we shall repeatedly return. Either the change of laws is itself law-governed, or it is not. If it is, the higher level laws must themselves be subject to change. Otherwise, we would have to stipulate, without reason to do so, that something in the world is exempt from time and change. If, however, the change of the laws is not itself law-governed, even in the sense of statistical determination, we would find ourselves face to face with arbitrariness in nature and with impotence in our explanatory efforts. These are real, not fanciful difficulties, requiring real answers. They highlight some of the riddles generated by the hypothesis of succession. However, they do not apply solely to our thinking about the origins of the universe. They shadow all our causal judgments and the whole of science. if we have reason to believe that the framework of natural laws, symmetries and constants is within time rather than outside, and if we must therefore reconsider the relation of mathematics to nature and to science, such change of the regularities of nature, however, may be discontinuous, as change in the part of the world of which we have direct experience generally is, sometimes fast and dramatic, at other times slow, imperceptible. Given these refinements, the idea of a succession of universes should be understood as shorthand for the conception of a history of the universe, passing through distinct phases or periods. Causal continuity and connection may be stressed and shaken rather than broken. On such a view, the substitution of succession for plurality in our ideas about the universe and about what lies beyond our ken does not amount to trading one enigma for another of the same order. The puzzles attending the idea of succession are those of the relation of the history of nature to the basis of our causal judgments. States of the world behind the veil of a traumatic transition, such as the formative moments of the observed world, observed universe, present obstacles to direct observation and experiment. However, they do not contradict the assumption of causal connection and continuity, nor do they appeal to metaphysical entities such as parallel worlds, inaccessible from our own, that could not even in principle be open to scientific investigation, however remote or indirect. They arise from a willingness to take the reality of time seriously and to treat the history of the universe as exhibiting a discontinuity more radical than the discontinuity that we see displayed in the history of each of its parts. Succession is not adequately described as plurality in the realm of time rather than of space. It is radical transformation in time of the one real universe. The finite and the infinite at the beginning of the universe. The characterization of the cosmological singularity is the first of several problems in contemporary cosmology that bring into focus the need to choose between plurality and succession, as well as succession with and without continuity across successive universes or periods of universal history of the same regularities of nature. Penrose and Hawking argue that given a cosmological space-time without spatial boundary, satisfying a small number of conditions, there is a temporal boundary in the past of finite proper time, beyond which the application of the field equations of general relativity cannot continue. This result is commonly interpreted to show that given the equations of general relativity, together with reasonable assumptions about the distribution of matter, there is a cosmological singularity in the past of our universe. By such a singularity is meant a moment of simultaneity at which all physical quantities such as temperature, density, and strength of the gravitational field are infinite. Upon reaching the circumstance of the cosmological singularity, the field equations break down. It is impossible to continue solving them further into the past. Some Highland coffee. The Highlands of Costa Rica. Sorry about the intermission. The theory seems to give more precise expression and foundation to the dominant view of the origins of our universe. The Big Bang cosmology. It appears to imply that the universe began a finite time ago and out of nothing. In the moment of the infinite natural quantities and of the undivided unity of all matter and all forces, the laws, regularities, and symmetries of nature did not yet hold. Time itself, according to this view, did not exist. It emerged once the threshold of the singularity was passed. Once out of the singularity, the universe began to assume the form that we are able, directly or indirectly, to observe a manifold of distinct structures and forces, deeply united and subject to a timeless set of laws governing events situated in emergent time. Although this conception does not necessarily imply a plurality of universes, it characterizes the initial formative moment as so arbitrary, so far beyond the reach of observation and explanation alike, that it removes the initial bar in our thinking against the idea of other universes. Also causally closed and causally unconnected with our own. That might have begun or might begin in similarly mysterious circumstances. If the miracle of making something of nothing can be performed once, why can it not be performed often? Like Hugh Everett. There are 4 major objections to the inference of an infinite initial singularity. A first objection on the inclusive reality of time is that the inference of an infinite initial singularity is best understood as an indication of the breakdown of the underlying theory, when its field equations are carried out beyond the proper domain of application, rather than as the description of an actual state of affairs. The mathematical idea of the infinite is not realized in nature. Its introduction represents a salient example of the dangers of succumbing to the views that mathematics offers a reliable shortcut to insight into the workings of nature. A second objection is to the very notion of something arising out of nothing. No material, no agent, no circumstance, no time. A plausible interpretation of such a view is that it is less, in this respect, an account of the beginnings of the universe than it is a confession of our inability to provide such an account. It seems better simply to acknowledge that inability than to conceal it under a genealogy that we cannot translate into any discourse of causal explanation familiar to us in science. Eat that, you Everett. A third objection is that the passage from the lawless world before time and distinction to the lawful world of distinction and time is not only unknown but impossible to represent persuasively in either the verbal or the mathematical language of science. At some point, we are asked to believe infinite quantities became finite. A distinct structure of nature emerged. The laws governing it began to apply, and time started to flow. That we cannot explain such a transformation may be conceded. What is harder to accept is that we cannot even describe it. The how remains as impenetrable as the why. A fourth objection is that these suppositions about the infinite initial singularity are not only hard to square with the rest of the way in which we think about nature, they are also difficult to reconcile with some of the empirical implications of contemporary physics. The picture of the singularity as the emergence of something out of nothing cannot easily be reconciled. If it can be reconciled at all, with a view from quantum mechanics. when that view is taken into account, the cosmological singularity appears to be an extraordinarily, but not infinitely violent event, in which very large but not infinite temperatures and densities prevailed. There is an infinite difference between the finite and the infinite. Right? The view of the earliest formative events in the history of the universe as capable of breaking and changing laws, symmetries, and constants, and of the confounding forces and phenomena that we observe divided in the subsequent universe does not require any suspension of causality and time. On the contrary, it points toward an extension of the universe back into time, back into a time prior to this violent event, when other laws may have held. It points us towards succession in the qualified sense in which I have described it. Rather than to plurality, and for the reasons that I earlier adduced, to non-cyclic rather than to cyclic succession. It is a matter of indifference or convenience whether we call the world before this formative movement an earlier state of the universe or an earlier universe. Given the postulate of causal connection and continuity, this previous universe, or this earlier state of the universe, is in principle open to empirical inquiry. Between it and ourselves stand the fiery beginnings of the present universe, reinterpreted in a fashion that brings them into the realm of time and change. If we suppose that the composition and structure of the world changed more rapidly and radically around the time of those events than they have changed since then, we can expect that our ability to inquire into this early history of the universe will be limited. However, it will not vanish. For one thing, there may, on this view, be only a difference of degree, although a substantial one, between the mutability of the laws of nature as well as of the causal explanations that rely on them. During that formative trauma and their mutability before and after it. I later consider the reasons to believe that time is more real than the dominant tradition of natural science has generally acknowledged it to be. That an implication of its reality, together with its inclusiveness, is that nothing in nature, not even its most basic structures and regularities, remains exempt from time and change. It is nevertheless important to reconcile the mutability of the laws, symmetries, and supposed constants of nature with the stability in the cooled down universe. The mutabilities of the laws of nature introduces a series of intractable difficulties. Whether we should regard these problems as insuperable antinomies or merely as enigmas that will only slowly yield their secrets, forms part of what there is to discuss. The laws of nature may develop coevally with the phenomena they govern. Causality may exist without laws. These ideas may shock in physics. They have, however, long been familiar in the life sciences, as well as in our ideas about society and its history. For another thing, a previous state of the world must have left some trace of itself in a later state. If the difference between the cooling universe organized as a differentiated structure and its superhot and conflating initial state is finite rather than infinite, no absolute barrier exists to the survival of such traces. Among them may be, for example, the seemingly arbitrary but precise values of some of the constants of nature, unexplained by the laws of the post-traumatic universe. The initial conditions of the history of the universe. A second controversy revealing the implications of the choice between the thesis of plurality and the thesis of uniqueness and of non-cyclic succession is the way in which we account for the initial conditions of the universe. Because the universe is believed to have begun with a non-zero temperature, it requires an indefinitely large or even infinite amount of information to describe its initial microscopic state. Another way of saying this is that the universe sprang into existence complete with an infinite number of degrees of freedom, excited to particular states. General relativity, together with quantum field theory, our most credible present comprehensive account of the universe, has an infinite number of solutions. Indeed, there are an infinite number of solutions that agree with observations and have a cosmological singularity in their past. Such alternative solutions and the alternative states of affair that they represent differ by the exact states of the particles and of radiation. the universe started very hot and hence full of photons and other particles. The alternative solutions and states of affairs also differ by the disposition of the gravitational waves. Small deviations from symmetry. Of these facts, the initial condition of the universe just after singularity seem to defy explanation and appeal to stochastic causation to the account for such a circumstance will confront the obstacle that the conditions are lacking for a well-formed probabilistic determinism. Ordinary probabilistic analysis conforms to the condition that the sum over all probabilities for exclusive outcome is equal to 1. We have no basis under these conditions to define that sum. We do not know the range of the alternative states to which the probabilities apply. We cannot treat as stable and well-defined the elementary constituents whose combinations the statistical accounts would be designed to explain. For we are witnessing the process of their emergence and differentiation. We are not able to trace the boundaries between the phenomena subject to statistical explanation and those subject to deterministic causation. At the root of these problems lies confusion between probability within the universe and probability about the universe. Stochastic reasoning applies within the universe. It cannot apply to the making of or to the history of the universe, if the universe is one of a kind. The multiverse conception tries to re-establish conditions for the application of probabilistic thinking to the universe. It does so by fabricating imaginary universes. The array of universes under the multiverse idea is limited only by the vast number of conjectural universes accommodated by the mathematics of an underdetermining physical theory. The string theory variant of particle physics. We cannot confidently use probabilistic reasoning in such a circumstance, even under cover of a view that was designed in part to facilitate its use. We will have no easier time in deploying deterministic causation. The canonical model of deterministic explanation in science for the last several hundred years has been the Newtonian paradigm. The distinction between the initial conditions of a set of phenomena and the laws governing their movement or change within a given configuration space bounded by those conditions. What counts as stipulated initial conditions in one explanation of one part of the universe can figure as the subject matter to be explained, the law-governed phenomena within the configuration space. For another explanation of another part of the universe. However, the initial conditions of the universe can never become the explanandum in such an iterative process. They are not a piece of nature. They are the whole of it at an earlier time. In the end, the initial conditions of the universe, as well as the supposedly timeless laws, symmetries, and constants of nature, remain always unexplained by successive applications of the Newtonian paradigm. So to speak, there is a trick going on here. And the trick is to use the explanandum, the explanation, as cause. So first, we try to explain how the universe came about. So you have a start here. Try to explain, explanandum. we get the initial conditions, and then we use them to explain the universe. And the permanent laws. Not easy to discover. This line of thinking is hidden beyond or beneath. It is incredibly brilliant to take it out into the open. It's a double, triple trickster, and it's also a double, triple trickster that we are infinitely, enormously used to since generations and generations. It infuses every aspect, and I also come to think it is in our bodies. This is misuse. As you have it, is a true depiction of slouched, collapsed. It needs to be understood. It cannot be criticized. Of course, this is an argument against a timeless universe, but there is a huge part of the book that is to be understood. So negation alone in this case is not enough. Negation and understanding. So it's a part of pedagogy. And if you've been reading the reviews over the net or in Scientific American or the New Scientist, also from New York Times, Washington Post, it seems, on good reasons, they haven't put enough time to read it, because it just takes a lot of time to understand and getting used to before the decisive movement can be done. You have to uncover things, not by criticizing, leave them as they are, generally perceived by everyone. But underneath that, here you find this triple momentum 22. Could it be called momentum 66 maybe? I would say it's actually quadruple, or 10 up to the 12th complication. I've seen a lot of physics books. I was especially interested in that one by Stephen Hawking. And there is pictures there, depiction of other universes and baby universes, and I like those pictures. But firstly now I realize they didn't depict anything of reality. And of course Stephen Hawking himself knew by his heart these universes could never ever, not even in principle, be seen, experienced, or indirectly induced. They never ever could leave a trace. They are causally unconnected. Talk about knowledge going wrong. Incredibly interesting. I say thank you very much, and do have a very pleasant morning. And here you can see the view once more. We have had sunshine coming up, disappearing, and for some reason even the Ferris wheel has been turning. I have no idea why though. But obviously we're not looking at a timeless scene here. It is not governed by eternal laws that can not be changed by time, because not even the laws are beyond time. And trying to explain the laws by using time puts us in the conundrum, as Smolin and Roberto points out. Then we say that there is something unknown, never to be known, more fundamental than time. And all explanations of time succumb to this, I realize. Whatever you do, you will happen to say that there is another explanation more fundamental than time that we can never, ever know. It is just trickier than trickier and trickier. This is the biggest trick of all. Well, okay. Bye bye.